Hi all, Dmitry is here. Welcome to my next video about AA battery testing. In comments below one of my previous videos you asked me to check Flarx batteries. Thank you for comments, thank you for your requests. Finally I got them, and finally I can satisfy this request. So let's check. We have here Zinc-carbon ones and we have alkaline ones. I think that these ones will be complete crap because it's really cheap Zinc-carbon, and I think these ones will be average, maybe a bit worse than average. But enough talking, let's test them. Let's start with alkalines. Okay, first alkaline is installed, and let's get data for them. Data collection for the Flarx alkaline is finished, and I guess I will not show you raw data for Flarx alkaline. I will quickly test these ones because I think capacity will be really low and they will die really fast, and then we will just take a look on the data and compare these kinds of batteries. So one moment. Zinc-carbon Flarx battery is installed, and let's check what capacity we will have here. I guess 600 milliamp hours. So write in the comments please what do you think, what capacity we will have here, and let's test it and see. And that's it. I collected all data for Flarx alkalines and these Zinc-carbons. Actually, for Zinc-carbons I conducted 4 tests, not 3 like usual, like normally, because capacity was even lower than I predicted, only 400 milliamp hours. So I did special test with only 50 milliamp discharge current. I thought maybe it will do some difference, but it looks like no. Let's take a look what do we have.
Let's take a look at the data that we collected for the Flarx batteries. Here you can see raw data for the Zinc-carbon batteries, and what's interesting here is, first one, internal resistance. It's really huge. So this battery is definitely not suitable for powerful loads. And when you increase the current for half ampere, as you can see, more of half work time, let's say runtime of the battery, will have voltage below 1 volt. So Zinc-carbons are completely not suitable for powerful loads, and they have really low, super low capacity. Let's take a look at the alkalines. And here we have alkalines, and this graph looks really weird to me. First moment is, again, internal resistance is really huge, and it is even slightly higher than it was for Zinc-carbon. And as you can see, graphs is a little bended. This voltage, capacity and power lines is little bended, especially power one. With time, and this seems really weird because we have really low capacity, really low current here, but it's still bended. And when we increase the current, it forms begin to be very more and more bended. And another interesting moment here is this voltage line looks more like just a straight line. It normally should contain first part when voltage will quickly drops, and it should stabilize on some plateau, and then it should quickly drop to almost 0. And here we see different picture. Here it's slowly dropping, and with increasing the current, it begin to be more and more looks like just straight line. This looks really weird. Okay, let's take a look at the summary. Here we have capacity comparison, and as you can see, capacity is not too bad actually for alkalines, but for zinc-carbon it's almost nothing, so I don't think that we should take zinc-carbons into account, so you should not buy zinc-carbons, Flarx zinc-carbons at any times. And for alkaline, yeah, capacity is decent at the low current, but with increasing current it's quickly falling. But if we will take a look at the energy, for zinc-carbon energy is dropping not so fast like for alkalines, but for zinc-carbons energy is really low from the very beginning. So again, from energy point of view, you should not use zinc-carbons. And alkalines actually maybe only good for the really low current, so maybe they will be good for, let's say, wall clock. But as for me, it's not suitable for some powerful loads. And let's take a look at the really special graph. This is graph how internal resistance changing when battery depleted. When battery discharging, its voltage dropping, and here we can see how internal resistance growing. Why this graph is important? Because when internal resistance will grow more than some threshold, this threshold is individual for every application, every load. When it will grow enough, your device will turn itself off, no matter how many energy remains inside the battery. So maybe it will deplete it only to 15%, but your device is not working anymore. And here we can see that at this point internal resistance begin grow quickly. So firstly, it's not really quickly growing for zinc-carbon, and then it begins to grow really quickly. So for zinc-carbon usage, usable capacity will be about 15%, I guess. But let's take a look at the alkaline graphs. It growing really quickly from the very beginning, and at the end of discharge, it even higher than for zinc-carbon. So, and please note that this graph is taken for current 0.1 amp. So with this, I think Flarx is not the best batteries that you can buy, and if you will buy them, buy only alkalines. So zinc-carbons looks bad from our point of views, and they tend to be leaky. So if you will leave them into your device, when they will discharge, they can leak and ruin your device. So thank you for watching, and thank you for asking me to do this review on the Flarx batteries. Please let me in comments below what do you want to see next, or maybe you have some ideas how to make these videos more interesting, better. Thank you, and have a nice day. Bye.